Hello, I'm JW. This time we're going to have a look at heating systems, and more specifically the electrical wiring for heating systems. And by heating we're talking about central heating, so you've got your boiler, radiators and usually a hot water cylinder. Now this will be in several parts, and this time we'll just have a look at the basic overview of the various components, and then in future parts we'll look at the various different types of systems which you can get. Now, a typical central heating system will have various components, and first of all, of course, it's the boiler, which is typically gas powered. There could be oil or even possibly electric, although nobody would actually want one of those. And this, of course, just heats up the water. And the second item is a pump, which we've just got here, and you're going to have at least one or more radiators to heat the rooms, and a hot water cylinder, of course, which is used to heat your hot water. And this is the type of system where the water inside is heated and stored there, and then of course is available for use when required. Now in terms of the plumbing parts, we'll just do a quick overview of this. You're going to have a pipe coming out of the boiler, going to the pump, and then from there you'll have the pipe coming out, and there'll be one or more valves, or in some cases just one, which will split the water flow, first of all to the hot water cylinder, and also to the radiators. And then from the radiators and also the hot water cylinder, there'll be the return of the water, which of course goes back into the boiler, and then the same of course applies to the hot water cylinder. And the hot water cylinder is a fairly straightforward device. Basically it's filled with water, and then inside is a coil of copper piping, and as hot water is circulated through, then it heats the water contained in the cylinder. And the water in the cylinder is what comes out of your hot taps. The two types of water, either in the cylinder and the coil, are two totally separate systems, and one does not ever mix with the other. Now in terms of actual controls of this system, of course the boiler requires an electricity supply, as does the pump, and it's often the case that the pump is wired actually directly to the boiler. The valve here can actually be a single valve, which just diverts water either to the hot water cylinder or the radiators, or both. And in some cases there may be actually two separate valves here, and those again are electrically operated, so of course you can select radiators, hot water, or both as required. And then your additional items, there will be a cylinder thermostat which is attached to the side of the hot water cylinder, and you can set the temperature on that as required to determine how hot you want the hot water to be. And then there'll also be a room thermostat, which is normally a wall mounted item, and that will switch on and off depending on the temperature of the room in which it is placed. And of course that's adjustable, so you can set the desired air temperature in your house. So in terms of electrical items, got the boiler, which requires an electricity supply, the pump, which requires obviously an electricity supply as well, one or more valves, which are again electrically operated, the cylinder thermostat, which obviously determines the temperature of your hot water, and then the room thermostat for setting the temperature of the rooms in your house. And when these are actually attached, there's generally some kind of timer or other control where you can obviously set the time that you want the boiler and the heating and the hot water to switch on and off, and that's generally called a programmer, which is again a wall mounted item, and typically has some sort of digital display on there, and various controls to set the time and duration the boiler will actually operate. And of course that also requires electrical connections and connecting to the other elements of the system. So you've got 6 items essentially which require electrical connections. You've got your boiler, the pump, one or more valves to control the flow of the water, cylinder thermostat for the hot water, room thermostat for the room temperature, and then a programmer or timer to determine the times that you want the system to actually be operating. So let's have a look at the boiler to start with. Now all boilers require a main supply, and that's normally provided via a 3 amp fused spur, or in other cases you could have a plug on there and just have a 3 amp fuse in that and plug that in. But in any case 3 amps is the usual rating. All of these components within the heating system are very low powered, and of course do not require any substantial amount of electricity, as all the heating is done by the gas or the oil fuel which the boiler uses. Now there's essentially 2 types of boiler. Older ones would just have the line, neutral and earth connections, And those particular types essentially operate so that when the power is connected, the boiler is actually operating and heating the water. And to stop it doing that, you just basically disconnect the power and it doesn't work anymore, of course. However, that's a fairly older type of boiler, and the majority of boilers these days require a permanent supply. And then they have a further switched line to determine whether the thing operates or not. So these three are connected to the permanent main supply. And then the switched live is only connected to live when you want the boiler to actually heat up and do its thing. So this is what goes off to the rest of the controls within the rest of the system. So that would be your thermostats and other devices. And most boilers these days are arranged in this format, although of course there are still plenty of old ones out there which just have the three connections and it's just basically on or off. And to activate the boiler, it's simply a question that the line is connected onto the switch line there, 230 volts, and then the boiler will switch on and heat the water. And a fair number of other boilers also have an additional connection, which is for the pump, which is usually referred to as PL, and that actually connects to the pump. And this is so that the pump is actually therefore controlled from the boiler itself, rather than the rest of the system. And that's generally done so that the pump can then be run on for a period of time once the boiler has actually switched off to dissipate any remaining heat in there. And in that case, it's just this goes straight to the line on the pump, and of course the neutral and earth connect to the pump in the same way. Again, some older systems have the pump connected elsewhere, but on new ones this by far is the most common arrangement. Now the second item is the pump or circulator, and as the name suggests, it circulates the water within the heating system and of course moves the hot water around so it gets to the radiators and the hot water cylinder. And pumps again are mains powered items. They require line, neutral and earth, and they're very simple devices. Essentially when the power is applied to the thing, the motor inside will operate, and of course it will circulate the water around the system, and when the power is disconnected, then of course it doesn't do any of those things, it just sits there doing nothing. And the pump is normally wired into either the boiler directly or into the rest of the control system. And that's really all there is to the pump. It's simply an on or off type of device. Plenty of pumps have a control on the side to select the various speeds required, but generally those are set when the system is installed, not something that needs to be altered or even considered afterwards. So it's simply a power connection to the pump, and when it's on, and when it's off, it's off. Now, to control the temperature within the building and the hot water, there's going to be at least two thermostats, one for the actual air temperature and the other one for the hot water. So we'll have a look at the room thermostat. And the thermostat is essentially a switch which is activated by the air temperature or the water temperature in the case of the hot water one. And as its most basic form, we'll have two connections. And then the thermostat is basically a switch fixed between those connections. So it's going to be line in and line out. And of course one of these is permanently connected to line and the other one goes back to the rest of the control system. And if the room is too cold, so therefore heat is required, then the switch will close and basically complete that circuit, therefore sending the line signal back to the rest of the system. And when the room heats up to the desired temperature, then the contacts will open, and therefore you don't get that line or live signal coming back to the rest of the system. So that's essentially all there is to it. So it's when heat is required, then the switch is on, and if heat is not required, then the switch is off. And of course the level at which it switches on and off is determined by the setting on the front, whether that's a mechanical dial or a digital type of setting. But they're all working the same way, essentially just a switch which is being switched on and off in response to the room temperature. Now in its most basic form, that is the only connections you would need, so simply a 2-core cable would be needed. However, when actually installing cabling for these, of course, you're going to be putting an earth connection to the position for the thermostat. Obviously a lot of thermostats don't need that, but of course some of them do. And normally a fair number of thermostats also need a neutral connection at the position of the thermostat. And this can provide one of several functions. On older thermostats, there's a neutral connection, and this actually goes via a small resistor inside, and that's connected back here to the switched line output. So in the off state, of course, nothing's actually happening, but when the heat is required in the room, that contact will close, so sending that live signal back to the rest of the system. And it will also cause this resistor here to heat up, and this is inside the thermostat. And the purpose of this heater is to actually heat the enclosure within the thermostat to a small degree, and this ensures that the actual contacts will open a fair bit sooner than they otherwise would have done. And the main purpose of this is to make sure it opens at the temperature you've set. Without this, the strip is actually fairly slow to respond to changes in air temperature, and you'd find that if, say, you set 20 centigrade on the thing, it might actually be sort of 24, 25 before the contacts actually opened. And of course, that is not exactly what you want. It would result in fairly large temperature swings within the room. So it's purely there as basically sort of a booster sort of heater to ensure that the contacts actually open and close rather more responsively. If this isn't connected, it will still work. So if there was no connection there, but you'll find that the temperature in the room tends to vary considerably as the metallic strip is fairly slow to actually respond. The other reason for putting a neutral there is that a fair number of thermostats are digital or electronic inside, even the ones with a dial on the front, and they do actually require a neutral to power the electronics. So you've got your switch here, which is normally in the form of a relay. And internally to the thermostat, the incoming live connection goes to a big box of electronics inside. And that's what actually does the sensing part. And then the switch here is actually controlled via a relay, via the electronics. So you need that permanent line and neutral supply to ensure that this is actually powered. Without it, the thermostat simply won't work. It'll just sit there on the wall doing absolutely nothing. And of course, the switch will remain permanently open and your heating simply won't work. And usually the ones with digital displays will require the additional electronic power. And also some of the dial ones, there's a Drayton one, which is a fairly common type, which although it has a dial on the front, the internal switching, again, is electronic. So without the power supply, it does not work. So normally for thermostats installing, you would want a 3-core and earth type of cable. And that will cover pretty much all of the most likely situations. And again, if you don't need all three, well, you just have to use 2 of them. So 3-core and earth cable is the usual choice to put to the position where the thermostat will be located. And the final type of thermostat is a wireless thermostat, which, as the name suggests, doesn't have any wires, or at least at the thermostat position. The only difference with those is that you have a wall-mounted thermostat, which is battery operated. And then elsewhere you have another box, which actually is the receiver for that, and that's mains powered and would have your usual wired connection to the rest of the system. The only benefit of these is that you don't have to put a cable from the actual controls or the boiler to the thermostat, so possibly maybe saving damaging the wallpaper or whatever. But in terms of connection, it's exactly the same. It's just that the connections are done at the remote receiver unit, not where the actual temperature sensing part is located. Of course, this type also costs considerably more than the permanently wired in variety. Now, the other thermostat, of course, is for the hot water, and generally that'll be on the hot water cylinder. So unsurprisingly enough, it's called a cylinder thermostat. Now, these are generally located on the side of the hot water cylinder, generally about a third up from the bottom of the cylinder. The older copper type ones, the thermostat is a separate item, which has to be supplied as a separate thing and wired in separately. And some of the newer cylinders, particularly the mains pressure ones, will have the thermostat already built in as part of the cylinder. But in any case, wiring for those is exactly the same. Now, a cylinder thermostat is still a switch, as in on and off, but in most cases it will have 3 connections to the switch. There's going to be line coming in, and then you're going to have 2 outputs, both of which could be live, and that depends on the positioning of the contact. And the contact is pivoted here, and it will either go to this output here, or in the other position it goes to the output over here. So in one case this one will have the line coming out on it, and then in the other case, say when the water is actually heated up, it will switch over to this one here, and then your line will come out on this terminal. This is called a changeover switch because it does change it over from one position to the other. Now the three terminals generally have sensible markings on them. The middle terminal is generally the common. That's where the power coming in is connected, and then the other two will typically be satisfied, which would indicate that the water is already hot enough, therefore heat is not required. And then the other one would be call for heat. And that's the one that would be connected if the water was too cold. So heat is required, or heat is not required, depending on the position of the actual contacts. And again, the temperature setting is done by a small dial or adjustment on the front of the device. Typically for hot water cylinders you're looking at about 65 degrees centigrade. Any more than that is likely to be severely dangerous because you're going to have scalding water coming out the taps, and less than this you're going to get Legionella disease and things growing in the cylinder, so you definitely want to be avoiding that, but this would kill off most of the bacteria inside. Now to actually determine when the system is going to switch on and off, you'll require a programmer, which essentially is just a timer, or in the case of central heating with hot water as well, with two timers generally contained within the same box. And this is the sort of thing you just set the times and possibly days as well that you want the heating and hot water systems to be switched on, and then this will switch them on and off at the times you have chosen. Older ones had a mechanical clock on the front as the timer, and of course newer ones generally have some electronic digital module in there, but the principle is exactly the same. Now all programmers require a mains supply, and this needs to be permanently on, because otherwise of course the programmer wouldn't actually work. So three terminals coming in, so you've got earth, neutral line there. The earth often isn't connected, it's just on a separate disconnected terminal, but nevertheless the earth should be taken to the device. And then inside there you'll have some kind of timing device, so either electronic or mechanical, and the neutral line will go straight into the timer, of course, so that it will actually operate. And for the output, typically on a two-channel programmer you'll have the hot water for one channel and the central heating for the other, and there'll be four output terminals, and those are numbered 1, 2, 3 and 4. And internally, so it's basically a set of switches, and it's connecting the incoming line here to the output terminals. So there'll be a contact coming down and another contact coming down over there. And the switching arrangement is that you've got a pair of terminals for the hot water, so one is on and one is off, and then the other pair of terminals is for the central heating, again that's on and off. And the contact on this side is generally the hot water option, so that will connect from here and over in this position. That's generally the hot water on. So if hot water is required, this terminal is then live, connected via the connection here. And the hot water off is normally the number 3 terminal here, so you've actually got that coming across. And then if hot water is not required, then that contact simply switches over to there, and then that's the hot water off. And the central heating is pretty much the same situation. You've only got the contact here, and then one of them actually comes across to the terminal number 2, and the other one goes to terminal number 4. And in the case of it being on, then it's coming across here, and that's your central heating on. And when the heating is not required, that goes across to here, and then that's the central heating off. Most two-channel programs are actually arranged in this order, and they usually have a standard plate which screws on the wall and the programmer just clips onto the front. So in most cases you can just simply take the programmer off and just clip a new one on the front if it needs to be replaced. and because these are all in the same order usually, don't actually have to change any of the wiring. This also means it's very easy to test whether the rest of the system is working and the programmer is actually at fault, simply by removing the program from the wall plate and then installing a manual link, say from the L terminal to number 1, and that would switch on the hot water, or from the L terminal to number 2, which then would switch on the central heating, and conversely with the off terminals as well. But essentially inside it's just a set of switches, and in any case either the hot water on or the off will be connected to live, or the heating on or off will be connected to live as well. And the final component of any heating system is the valves, and these are what controls the flow of water through the system. Now there are several types of valves available, but the most common, or the most simple at least, is one which simply has two plumbing connections, and you consider it as basically a section of pipe there. So we've got water coming in here, and then water goes out at the other side. And in the middle here there's usually a box of controls here, and this will activate some kind of device in here. And then you've got your electrical wiring coming off. And on this particular type, which is by far the most common, in the box here is a spring and a motor. Now when there's no power connected, the spring holds the thing closed, so no water can actually get past. The water obviously doesn't flow through, and that's its default state with no power applied. So no power, no water going through. Now when you apply power to the motor, which is a mains powered thing, 230 volts, the motor will work against the spring and essentially open the valve here, and normally it's some kind of ball or type arrangement, but we'll just say let's just open that up. So when power is applied, the valve is opened, and of course water can flow through and go out the other side. So when power is connected, water will flow through there. And note it's necessary to keep the power applied for the whole time you want the water to be flowing. So whilst the valve is open and water's moving, mains power is continuously connected. And that does use a certain amount of electricity, because of course the motor is still powered even though it's not actually moving. And of course when you turn off the power, the spring again takes over and just moves that thing into the closed position, so no water will actually flow in there. And the motor is a mains powered thing, so your connections here will just be your normal line, neutral and earth. Valves generally have metal bodies, so earth connection is essential. Now for heating systems there's normally an additional component inside, which is a switch. And just like thermostats, that's just an on and off device, and that's generally brought out on two additional wires outside, so it's fairly common you get a 5-core wire attached to these, and most valves are actually supplied with the length of 5-core flex already attached. And the switch, when there's no power and the valve is essentially closed, then the switch is actually open, so we'll put open. So these two things are not connected. However, when you apply power, of course the motor will activate, opening the valve there, and when it gets to the end of its basic travel, so in other words the thing is fully open, that will then cause the switch to close. So these two wires are now connected, and then the switch is essentially closed or on. And this is used to signify to the rest of the system that the valve has in fact opened, and then this is what's normally used to switch on the boiler, pump and other devices. This is done so that if something went wrong with the valve internally, say the pin sheared off or something, then you wouldn't actually get the boiler working, and of course you wouldn't want the boiler working if this was closed, because it would essentially try and heat water, there would be no circulation and the thing would overheat and possibly cause damage. So the switch is basically there as a switching mechanism, and that's what actually turns on the boiler and the pump when the thing is open. So although the program and thermostats are there, the actual boiler switching is done via the switch inside the valve. And for this type of valve you would have two of these in the system, one for the hot water flow and the other one for the central heating. Now you can get another type of valve which has 3 connections, essentially 1 in and 2 out, and that can actually be used in place of 2 of these, and we'll look at that in the video later on because that's a fairly involved piece of equipment. So let's look at the different parts of a central heating system, particularly how they would be wired up electrically, and in the next video we'll have a look at how those things are actually all wired together and the different types of a system that you can encounter, and of course how to troubleshoot and wire those in. So until next time, thanks for watching.